Work it, make it, do it, make sense.
All right, welcome you guys to AI for All Devs. Hopefully I will prove that to be the case. What we're going to talk about today, our agenda is kind of packed, so I'm going to try not to go fast. If I start to speed up, just tell me to slow it down. I would rather miss not doing something than to make sure you don't understand. All right, so our agenda is as follows. I'm going to introduce myself, and then we're going to talk about the differences of AI, machine learning, and deep learning. And this is going to be really important as we get into AI for all devs, because I find that when I talk to a lot of people about AI, these three terms have gotten mushed together, and they're really not clear. So I want to make sure they're clear before we go forward. Then I'm going to introduce Amazon AI, so that's more than just the services I'm going to cover here. And then we're going to dive into some of the AI technologies that you guys can get started with today and put in your applications. And then at the end, we'll talk, we'll chat, or you'll throw tomatoes at me, one of the two. And then we'll hopefully it'll be a good session. All right. So who am I? Really quickly, I am Tara Walker. I am a software engineer that talks to people. That's where the evangelist comes from. So I always tell people, especially when I'm in the United States, I can't save your soul. If you thought that's what evangelist meant, it's about technology. But I had worked for Amazon Web Services. I've been at Amazon about 3 years. And prior to that, I was at Microsoft for 12 years. And then I did the gamut of the Ma Bells and the Time Warners. So that's me. Let's get into it. So when we talk about AI, what are the differences of that? Let's explain AI versus machine learning versus deep learning. First of all, AI is what you probably think it is, human-like decision makings or intelligence displayed by machines. Now, typically when you hear people talk about AI today, they're talking about machine-based learning. But really, there are two types of AI. One is denoted as like a general AI, and the other is denoted of a narrow AI. So the narrow AI is what you think about when you think about CP3PO in Star Wars or the Terminator. Everyone's like, oh no, Skynet is coming to get us. That's really narrow AI. And we haven't gotten there yet. In fact, AI is really not a new concept. The Turing test actually said that a machine can really, if they can fool someone to think that it's a person, then we've actually accomplished narrow AI. Now, it took us 60 years to do that, but we've only had one computer that actually fooled a bunch of judges. That happened in June of 2014. And based upon the Turing test for narrow AI, over 30% of the judges would have to believe that they were talking to a real human being. And so this was a chatbot that actually did that, and that was called Eugene. It fooled 33% of the judges that it actually was talking to a 13-year-old kid. But again, we're not there yet. So typically when you think about AI, think about general AI. This is what we're going to talk about today. And these are machines that have human characteristics or show some type of predictive analysis or intelligence as if we would make those decisions. We haven't quite gotten to the narrow AI. So two types. So then what is machine learning? Machine learning is a way to achieve artificial intelligence. So it's really just a practice. It's a theory. You use algorithms, you parse large amounts of data, you learn from that data, and then you can make predictive apps or solutions with it. That's machine learning. And there are three types of machine learning. One is supervised, one is unsupervised, and one is semi-supervised. Now, if I was running a narrow AI, then I would be doing an unsupervised AI. That means the machine is actually working, it's thinking for itself. Again, that's unsupervised AI. But machine learning and these concepts of machine learning is what enables artificial intelligence. So I don't believe in reading the slides. You guys can see that. But again, there are three types. And right now, what you'll find is a mixture of what we call semi-supervised. So you guys, we're taking advantage of all these different data models and other things that are out there. And then we're actually either running a program to simulate some type of predictive intelligence, or we built a program that has some level of, I can make these decisions. So here's the third one, deep learning. Like I said, they're all mushed. So if AI is machines exhibiting human-like intelligence, and there's two types, and then machine learning has three types of machine learning, and it's predictive algorithm and analysis, what is deep learning? Deep learning is a method or a implementation of machine learning. See how this kind of goes down? So it's really an algorithmic technique. And what it's based upon is actually the way our brains work. So our brains work on what you call neural networks. That's actually where that term comes from. And the reason why this technique has become really, really like hot right now is because out of all the machine learning techniques and algorithms, this one produces results the quickest. And obviously, if you think about it, if we're trying to get to that narrow AI, some people don't want to get there, but if we're trying to get to narrow AI, you need to have these results happen quickly. So a neural network, again, the way the brain works is any synapse fires to the closest one, it sends signals. And there's many synapses that are firing at one time. Just like in a neural network, an artificial one, there are many layers. So one layer takes an input, it processes it, sends to the other layer, and so on and so forth. And then again, then you get a final result. So neural networks would exhibit, anyone want to guess what type of AI to really be a neural network? We talked about 3 machine learning types. What type of machine learning would a neural network exhibit? Anyone want to guess? Unsupervised, right. In fact, it would not really be a neural network if it was supervised. The whole point of neural networks and using machine learning and producing more quickly is that the iterations actually learn from each other. So again, unsupervised. So that was great. We went through all of that. That's wonderful. So internally, as we keep going through all these turns, AWS, okay, can we actually help people who are not data scientists put intelligence at every application, every solution they want to do? And this is where kind of the concept of Amazon AI came up. So what does that look like? That's the eye chart, right? So if you think about it, take all this stuff that you see on the screen as you probably can barely read, but there are 3 main parts of AI. And this is existed, we're talking about Amazon today, but this is pretty common across most of the cloud providers. You're going to have a managed AI service, which means any developer without any knowledge of AI could immediately jump right in and then start to develop and use intelligence using AI services. Then you have AI platforms. These are for people that, hey, I'm a little bit more savvy in this machine learning space. I want to train my own models to enable AI with machine learning. So you have the machine learning platforms. And then you have the frameworks. This is where you are really phenomenal when it comes to AI. You know how to pull your data. You know how to build a neural network. Well, again, still, these frameworks still make it easier for you to do that. So again, 3 levels. Of course, there's the infrastructure that runs the AI, and you can see that there at the bottom. But if you think about what's common across most cloud providers and most AI providers, there are the services, there are the platforms, and the frameworks. So how does this fit in what you need? Pretty much, it's your needs, your choice. If you want to use AI-enabled managed API services, then you would take the top layer. So that's poly, recognition, and Lex, some of the things we're going to talk about today, and immediately put natural user interfaces into your application. If you really want to build your own type of deep learning model that maybe either doesn't exist today or possibly it does, the one thing that enables deep learning today is the fact that we've been collecting all of this massive amounts of data, and now we finally have an opportunity to do something with it to train models. Well, maybe you have access to these huge amounts of data sets. You might want to take a deep learning framework and do that yourself. So from an Amazon perspective, we support all of the frameworks, MSNet, TensorFlow, all the ones you probably have heard of and played with. Or you can, again, take advantage of the work we've done with neural networks and then use the managed services. So before I get into those managed services, because that's where we're here, AI for all devs, let's talk about what you have if you're one of those people that are raring to go and want to run a framework. We have what we call a deep learning AMI. That's just simply a container. It's a VM. You go and you pick it, you run it on EC2. It has every neural network or every machine learning framework that exists today, pretty much. I literally listed them out here. It's already pre-installed with them. It's a really pretty robust machine. All of the drivers that you need are already installed. We actually support this AMI. So you literally can get up and running with one click to start your own deep learning framework. In addition to that AMI, we have a template that'll set up all the resources, instances, workers, your own VPC, auto scaling groups, master instance, and then two worker instances there. So again, if you really want to get into a deep learning framework and you're like, yeah, I want to do the hard stuff, which is great, we actually try to make it easier for you to get there. So again, as a part of it, which we won't dive into today, but I would be remiss if I didn't talk about it. Now, I told you that we have all of these different frameworks. There's one that we've kind of narrowed in on, and all of the other services that I'm going to talk about today and show you code with today are actually built upon the premise of this framework. That's the Apache MSNet framework. So why did we decide to settle on this one? Well, first of all, it's the most open. So we're really, if you weren't aware, really big about using things that are open that other people can not only help us to build different things on, but it can be expanded with the wealth and number of developers out there. So that was the first reason. The second reason is it's really portable. So you can make models, whether it be for mobile or IoT. And all of the managed services that you see that I'm going to talk about are based upon us leveraging MSNet ourselves. Now, if you want to get started with MSNet, we literally have labs, workbooks already out there, Jupyter notebooks already configured for you to get you up and running really quickly. So in combination with that and the AMI and the Cloud Formation template, if you're really into MSNet, you have an opportunity to get in there. So that's kind of wanted to make sure I did the background and everything else. But again, MSNet is available for you as well. That is a deep learning framework, and I just want to see if you guys actually paid attention to me. So if that is a deep learning framework, MSNet, it is using what? Anyone? So no one's paying attention to me. It's using a neural network, which means it is leveraging the larger one. So it's an unsupervised machine learning using a neural network. So that's the deep learning engine, MSNet. So the services that we're talking about that provide services for all devs, AI for all devs, the ones I'm going to focus on today, we talked about MSNet. There's no way I can set up an MSNet instance in the 39 minutes I have left. I'm going to try to get to the other ones in that time. But the ones we're going to focus on today are Poly, Recognition, or Lex. Has anyone heard of any of these before I go on? 3 people. Wow. We're not doing a great job of talking about these, huh? All right. So, more people will learn about them today. So really quickly, Poly is lifelike text to speech. Recognition is image analysis, and Lex is conversational engine. Did you have a question? Yeah.
You have also a speech-to-text service?
Say again?
Do you have also a speech-to-text service?
Yes, so Poly does both. We're going to go through that. I'll show you. And Lex does as well. All right, so got it? Great. We talked about AI. We did all the background. Let's dig into the services and the code. The first service I'm going to talk about is recognition. So recognition is for image recognition service. It is managed. So all you have to do is access an API, and you're off to the races and actually using the neural network that we created and the models we created to detect different images. This does not just relate to faces. So this is object and scene detection. This is facial analysis, comparison, facial recognition. Again, these are things that Amazon Recognition will do for you. And it runs in the cloud. It's a managed service, as I noted. So what you have to do is simply leverage an API or SDK and upload an image, and you're off to the races. So again, 4 things that Amazon Recognition does. So if I wanted to, for instance, detect an object, I literally say, hey, I want to detect the labels of the different objects in here. So you see that this is a picture of a city. And if I ran this code against this image, what it would give me back is labels and the confidence of what that actually happened. So you'll see that I said I want a minimum confidence of 50. And I just printed it out in JSON. We're going to actually see this in the demo. But with 91% confidence in that image, it knows that it could label a city. And then with another 91% instance, it could say, okay, this looks like it was a metropolis. And then it's a building, it's a high rise, it's a dock, blah, blah, blah. And these are the actual confidence that it feels as though, based upon the model, these actually are in there. So let's actually get into a demo. I've been talking for a while, so let's look at some code. So what we're going to do today, I didn't want to do a demo that everyone keeps doing. Everyone takes a picture and they crop something over it. So I wanted to do something a little bit more risque. Hopefully my screen is going to come back in a second. I wanted to do something a little bit more risque. So I'm going to run this first and then I'll go through the code with you. So what this solution is going to do, I actually took the motion detection out of it because it's a little interesting having motion detection and it's just me standing up here. It's better when other people are around. But what I have here, because I took the motion detection out, is it's going to use my webcam. I'm going to click a button. It's going to take a picture of me, and it's going to determine whether or not I'm happy or sad, how old I am, blah, 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 things of that nature. Now, typically, when I wrote this initially, it was for motion. So the minute someone walked past, it would immediately capture you and determine whether you were male or female, you were happy, you were sad, et cetera, et cetera. Kind of hard to do standing up here alone. So I created a huge, ugly button that you'll see in a minute. So we'll run this first, and then I'll show you the code. So I don't know what I did to change that while that's doing that, but we'll see. All right, so this is me. I'm going to, here's my big ugly button, hit capture a picture. That's a weird, interesting button. Picture. So it says I'm happy. I don't know if that's it, but it's only 21% I'm happy, so that's pretty accurate. It thinks I'm a male. I have on a hat, so okay, I don't know how that's going. I'm not smiling. I'm between 26 and 43 years old. I don't have a mustache. That's pretty good. I don't have a beard, and I'm wearing glasses. Let's do one more of those and see if I can look a little bit more like a female with my hat on. I still look like a male with my hat on. At least it has a better confidence that I'm happy. So, okay. All right, so let's talk about what's happening here, and then I'll show you the code. So what I have here is just simply a webcam. Like I said, I changed the code a little bit. It usually detects motion. So you see this webcam, it's always on. So typically what happens, that button is usually not there. Someone walks past, it captures pictures every second, and then it just spits out who you are. Here, it's kind of odd to do here, so I have a button there. But let's look at, I only put back a subset of things that come back. Let me show you actually what happens in the code. So I'm going to close this down, and I'm going to actually go to the code and explain it to you. First thing, let me close some of this and get some more real estate so you can see. I'm just going to show you the pertinent stuff. So what I'm doing here is, after I do all the credential stuff and all the other try-catch, we have an API. I'm using the Java SDK. I'm using the Eclipse toolkit here. We have an Amazon recognition client, right? So I live in the East in the US, so I didn't change it. I probably should have, but I didn't. So I am saying I want to be in this region. I'm passing my credentials that are there, and then I'm having it to build this. So then it does a compile. Now you have different requests. If you saw the image that the code on the screen had, that was for objects. So I wanted to detect labels. Here I wanted to detect faces. So this is a different API. There's several of them. I'm just showing you two. So what I want to do to detect faces, and this, you can actually do a face collection here, but obviously I'm just doing one, so that code is taken out. But what I'm doing here is I'm detecting the face, and I'm actually taking the image as it gets clicked in real time, and I'm converting that into a byte buffer. And then I say I want all of the attributes to come back that it detects on my face. After it does that, now multiple people can be obviously in the picture. And you'll see that code is still there. I'm just not really showing it to you on the screen. I'm actually taking, this is some of the stuff I added. I'm just taking the first face, because it's just going to be me up here. And then I am running a little function I have to update face info to get the UI to update. That's boring. What's really more important is when the face details comes back, so there can be multiple faces here, I am actually saying I want every attribute that it can ever come back with. So like for instance, the detected face range, different set of attributes. So I want to show you what's all coming back because I literally wrote this out as a stack trace because I knew I was going to be here so you can see how much stuff comes back. I promise you I'm not going to scroll that fast. So when I clicked the button before, it detected the face 26 to 43. The bounding box is the demo you typically see people do. So they take that bounding box and that's when you can put another image on top. That's where that bounding box is coming back. The age range only happens if you say you want all attributes. It determines whether I'm smiling, if I have eyeglasses on, sunglasses, gender, beard, mustache, if my eyes are open, if my mouth is closed. And if you'll see with all of these, it gives me a confidence level on whether or not it believes this is the case. So if my mouth is open, what kind of emotions I have. You notice it wasn't sure about my emotions. The highest it got was 29. And you'll notice I'm only sending back one emotion. But that's not what the service does. It actually captures every emotion it perceives you to be. So here you see, I just on the screen just came back happy, but you see it detected three things. It wasn't sure whether I was happy, calm, or angry. But you notice the lower the percentage, the less likely it is the case. And then it gives you landmarks of your face. So where your left eye is, where your right eye is, where your nose, your mouth, left pupil, et cetera, et cetera. Your brow up, brow left, brow right, things of that nature. So I could keep going down. It pretty much gives you a lot of information that comes back. More than what I obviously showed you because all of that couldn't fit on the screen. And then finally, it gives you what we call a pose and a quality. Now I'm going to make a point of saying something here about the quality. With the network, so you saw how I wasn't sure whether I was male or female. I don't know how I should feel about that. But your brightness or your sharpness, when you're taking a picture, you'll find, so just something to know as you use the service, the clearer the picture is, the appropriate light, the more accurate it'll be. That makes sense, right? So you'll find that in low light conditions or odd conditions, you may not get as much accuracy. So that's nothing we did wrong, I promise you. It's just simply, it's trying to detect what it can, and then it's actually picking up those shadows. So I wanted to say that because last time I did this talk, someone was like, this doesn't work at all, blah, blah, blah. But it's because of the shadows. All right, so let's go back to the slide. It's a lot more code there, but since my time is waning, I want to keep going. All right. So as the screen comes back, we talked about recognition. So that's image recognition, facial recognition, et cetera. That models are for that. What we also have is Amazon Polly. And this is lifelike text-to-speech. So the point of Polly is that it's accurate text processing. It's intelligible and easy to understand, and it's supposed to add semantic meaning to your text. So if I have a customized pronunciation for something, you can actually put that into the text and then have it real time say it as you wanted to say it. The trick about this also, which is really great, is it has 47 different voices across 24 languages. So it's not just one language here. You can actually have the text spit back out to you in the dialect that you wish. So let's talk about Polly for a minute. Today, if I put in text that says, today it is Seattle, Washington, but we're nowhere close to there, but okay. And I run that through Polly, it should come out and say, I don't hear it. Yeah, I don't hear anything going on.
Today in Seattle, Washington, it's 11 degrees Fahrenheit.
All right, so that's what you expected it to say, right? Well, what about, here's where semantics comes in. So all I did here was, and this is literally what I did, and I'll show you in a minute when I go to Polly. I literally typed in something, and then I put it in Polly, and it takes that text and it spits it out in audio. This can happen either via API, CLI, or a console. Simple, right? What about Richard's number? Now, this is a computer. So how does it know that, if I send this through Polly, right, Richard's number, what do you think Richard's number is going to come out as?
Richard's number is 2,122,341,237.
Right? That's not Richard's number. But this is a great thing about Polly is I can say that Richard's numbers isn't 2 billion, blah, 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 blah. It's actually a telephone. So we can add semantic meaning to the text, and then therefore, then Polly can actually speak it as it's supposed to go, right? So instead of being 2 million, blah, 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 if I add semantic meaning, and you see here, I have the semantic meaning that says this is actually a telephone number.
Richard's number is 212-234-1237.
Right? So that makes more sense. So you can, with Polly, you just don't spit out just, oh, this is text to speech. You actually can put semantics into your text to say, I want it to say this is a telephone number. I want this pronunciation to be this. I also want to make sure that, I speak in this dialect. So the way this works is it's something called speech marks and SSML. So let's talk about that really quickly. Speech marks, let's say you wanted to build an audiobook, and there's a great lab out there for this if you guys are interested in it. If you're building an audiobook, right, there are certain things on the page where you need to pause. There are certain things you need to not only pause, you need to say things louder or softer. You may want to raise your voice. You need to know when the sentence actually ends because there's a pause there or a comma. So speech marks actually gives you that type of information. That's the metadata that if I go into Polly, and we'll do that in a minute, I can say, hey, I want you to describe when a sentence ends and when it starts. So what happens with Polly at that point, instead of just giving you back an audio stream, it gives you back metadata about the actual text that came in, and then the stream matches to it. The thing that gets it to talk soft or happy or sad or whispering, that's the new one we have out, whispering marks, that I talked about in the AWS blog, is SSML. And this is a standard, and it's just to assist you with speech synthesis. So that put the link there if people are really geeking out and want to talk about it or whatever. There are some limitations. You have to, of course, read about it. We don't support all of the tags. We support most of them, but there's a few. Like, for instance, if I wanted to use a Parasi tag, I don't support values that are lower than 80%. So if you think about decibel values and how quality values, if I can't do 80%, then I may not be able to get the speech marks correctly. So again, a few limitations, not a many. But a SSML example is what I have here. And so what I'm actually going to do is take this text off my PowerPoint, because this is actually a real thing, and have it show what it would say. So, all right. So I'm going to copy this. I'm not going to do it first, but just to show you that this is actually real. Where is it? Did I close it down? Okay, no, I didn't. Okay, good. All right, so let me blow this up. All right, so this is Polly. First of all, as I talked about, you can have the plain text speech here, right? So I can just say, hi, hanging out at, I wonder how it's going to say this without speech marks. That would be interesting to see. All right, so hi, hanging out at DevOps UK. So I can.
Hi, hanging out at DevOps UK.
Oh, okay. Did it pretty well. All right, okay. So obviously if I just put in different speech, it'll just come out, right? And then there's a bunch more voices here.
Hi, hanging out at DevOps UK.
And, Joey, whatever.
Hi, hanging out at DevOps UK.
All right, Joey. Okay, so here I can actually customize pronunciation. And how that happens is you can upload a lexicon there. But we were talking about, if I'm just in the console right now, we were talking about SSML, right? So you see right now it says, hi, my name is Joey. I'll read to you any text you type here, right? So I'm just going to, right?
Hi, my name is Joey. I will read any text you type here.
Right? Okay, so if I put what I said I was going to do. Take the actual things from my slide. I'll explain this in a second. There we go. All right. So the first tag that you'll see is called speak. You can do this in code. You can do this in the CLI. Like I said, the best thing I always do before I try to write code against this is test it here and make sure I'm not doing something really bad or making someone say something really bad. So the first tag you'll see here in SSML, if you wanted to speak, is actually the speech tab. That's actually a standard there. Then this next tag is what actually says, I want you to speak slowly, I want you to speak quickly, etc., etc. I should have actually brought up the list of tags there. But so if I change this now, I have invalid. So let's see, where's my tag that is gone? This is always the trick, right? Finding the broken tag. Let's see. That's closed. That's closed.
Single quotes versus double quotes.
Thank you. Let's try that. I knew it was something silly. Let's see. Still doesn't like it. Let's see. What do I have that's wrong here? Let me try my double back. This is the problem when I switch between Mac and Windows. I never know what to expect with the quotes. I should probably just stick with my machine. All right. Still does not like it. All right, I know I only have 20 minutes left, but I so want to fix it. Okay, I won't. I will try not to be anal retentive and not, because I really want to fix this now.
The speak tag shouldn't go around the whole thing.
That is, yeah, good catch. Let's see.
The spelling of my last name is Walker.
That's really slow. So you can do different things with the tags here. Who did the good catch? All right, so believe it or not, anytime someone catches my mistake and I can catch it, I have a $100 AWS credits for you. Aha, see, now you guys want to be engaged right now. See, too late. All right, so you can change this and say fast or slow and things of that nature. And the trick is with this.
The spelling of my last name is Walker.
See, so it can get faster or whatever. So again, this is Poly. And if I really wanted to change the format, I just really quickly and do speech marks, I can actually go here and again, all of this is in code. So instead of immediately doing the speech, I can say I want speech marks because I wanted the audiobook. And I want to, do I have a full sentence? So I want to have a sentence. I want you to give me marks per word. So let's say you're doing the bouncy ball thing, whatever. So this is where speech marks comes into play. So if I change the file format here, you see two things happen. I still can listen to my speech and get my audio stream, but you'll notice it now says download speech marks. So that when I run these things through Poly, the verbiage that is going to come back is not just plain text and not just the SSML. It actually is going to have special tags that says this is when the sentence ends, this is when the sentence stops. I won't download that because I realize I have 18 minutes, so I got to go a little bit faster. Okay, if I'm going to get to Lex. All right, back to the slides. Come on, you can do it. Great. All right, so everyone should, crossing my fingers, know what this service is. So if you are not familiar with Alexa, so I heard that one of my compadres was downstairs doing Alexa workshops, skills. Okay, so Alexa, obviously you talk to the Echo, you say, hey Alexa, I want you to order me, book a hotel, or hey, don't let me forget to run around the block 3 times, or whatever you guys tell Alexa to do. The technology that enables Alexa, right, to have that natural speech interface is Amazon Lex. So the technology that allows you to speak to Alexa and you have that code word is now available to you to put into your applications. what this does here is you can obviously improve human interactions, and I have all of the great things that you can do with it. Oh, before I forget, we have a challenge, a Lex chatbot challenge going on with some pretty hefty prizes if you guys want to play with Slack and write a chat box. So if you're interested, just go to the AWS blog. I wrote about it and shared some code, what you guys can do about it. Okay, enough of that. Prizes, stuff like that. But if you want to play with Lex, that's a great way to get started. So what is Lex about? So how many of you have built anything with the Alexa skill? He was downstairs. Come on, guys. Seriously, no one went to the work. One guy. Just because you raised your hand, I got another $100 gift credit for you. So you guys want to, okay. I'll run out by the time you guys decide to engage. It's okay. All right, so let's talk about how this technology is enabled for Alexa and what you can do here. So if you've written anything with Alexa skill, some of this will seem very, very familiar. The first thing you do is you create an intent. Just what it sounds like, not the Android intents, but an intent that says, this is the action I want to have happen when the user talks to me. Now, let me say this about Lex. You do not have to say Alexa with Lex. You guys are programming this, not us. So there is no code word unless you determine you want a code word. And we're going to build a bot really quickly. So you'll see. But anyway, the intent is the first thing. So, for instance, this example is I want to book a hotel. Then you got to put everything in the utterances that you want the person to say that Alexa will respond to. So I would like to book a hotel. Book that hotel for me now. Can you book a hotel for me, please? Et cetera, et cetera, et cetera. Now, once you have the utterances in that you want them to respond to, then you need to put in the slots of what the possible answers are. Now, all of these don't have to be required. You'll see this in a minute. But some of them obviously have to be required. So if I need to book a hotel, obviously city is probably a good thing to know where you want me to book a hotel in. So that I may require that. The type of room, you may or may not want that to be required. That's fine. But again, that's what slots are for. The responses that you're going to give back based upon what they're saying. And there are things in those slots, responses, that you can say are required. And there are other things that can be optional. And then after you go through all of this, and you can tie this to Lambda, so I can then have this to go out. Let's say I make a bot that says, find me a hotel in the UK, and it says in what area, and it says, okay, near DevOps UK, and then, it might ask a few questions. Then I can have Lambda then go out, run an API, get data back from that, and then respond, with some type of intelligence. Very similar to what you see if you're building an Alexa bot. The only difference is I can now do this for anything, whether it be web, mobile, etc. All right. So let's get into building really, really quickly a quick chat bot. So I knew this was going to happen, that my time was going to be waning. So I actually started one. My goal was for us to build one together, but I knew I wasn't going to have time. I just knew it. All right, so we're going to go through this one, and we're going to try to build one really quickly, but let me just show you how this works. All right, so the first thing you'll see in the editor, let me just run this first. So there's two ways to, I don't know if I even went through this on the slide. I was going so fast. There's two ways to interface with Lex. I can either text, so text to speech, or just like Polly, and it uses some of that technology, or I can speak what I want. So typically Alexa just lets you speak. This allows you with Lex to have, that's why you can do things like with Slack or Facebook Messenger, etc. It takes both. So if let's see if this actually works. Let me explain it first. I have some sample utterances. I have a bunch of them. I want to order pizza, please. I want to order pizza. I want to order pizza of type, and you'll see these blue and different colors. I'll explain what that means in a minute. Can I get a pizza, please? Order a pizza for me, whatever. And then here are the slots, and I'll explain how you create your slots in a minute. But anytime I put in a slot how they may respond, so someone may say, I want to order a veggie pizza, right? So that's one of the requirements I need to order a pizza for you anyway. So I'm going to take that, if they say that, and automatically put it in a slot. So here's the different ones. And then I could put a confirmation prompt to say, thank you, ordered your pizza and stuff like that. Let's do the example first, and then we'll try to, in the little bit of time we have left, to quickly build one. So I want to do this for, oops, I should probably stop talking if I'm going to do audio input. It's not
Sorry, can you please repeat that?
Yeah, I knew you were going to say that because none of those utterances were right. All right, so I'm going to click the button and actually say what I'm supposed to say. I have to say, if I want a correct response, one of these. If I don't say the correct thing, this is where, and again, this is what you guys do, here's where the error handling comes in. And you see I have, sorry, could you please repeat that? I can say, what the heck are you talking about if I wanted to put that there? You probably shouldn't do that, but, you could do that. And it's going to allow me to try 5 times, and then finally it's going to say, hey, I can't understand you, goodbye. But you can change that to be whatever. So I said something wrong. It says, sorry, can you repeat that? This is in the console, but obviously my goal was to start up Android and see it in the mobile, but that is not going to happen. So let's just go with the console. All right, so if I actually now say what I'm supposed to say, I'll say I want to order a pizza. Let's do the whole thing. I want to order a pizza. So you see it?
Do you want a cheese, pepperoni, veggie, or all meat pizza?
So it asks me the options. So now I have to respond. Now, there's 2 ways that you can respond. Again, I'm talking to it because, again, talking, everybody's used to Alexa. I can also type what I want to say here as well. I don't have to talk. I don't have to just hit the button and talk to it. I can take that voice off and say, cheese. And then it'll come back. If you notice, this time it didn't talk to me because, again, I am typing. It's now thinking we have a conversation that maybe is over text, because this actually works over text as well. You can create Lex where you can text it to say something. Did I not mention that? Yeah. So you can text it to say, you can text it to do something, and it will. And it can either respond to you either via text or voice or the like. So you saw I typed I wanted cheese, and it says, what size pizza do I want? So if I go back and do it with voice, large, it'll take audio
What
input.
type of crust, thick or thin?
So again, these are questions that are going on here. So there's 2 things to note when you're developing against this, because I'm not going to have an opportunity in the 9 minutes I have left to show. I'll post my code to show you the code of what this will look like in code and doing this on an actual device. But 2 things you should note. There's 2 types of input that comes in. I talked about it, but this is where it becomes important. When you're going actually to doing speech, it's going to process things as what we call a post context, right? That's whether using SDK or API or over HTTP or whatever. If you're using voice, it's going to use what we call a post context. And that's important because the slots that it uses are a little bit, just very slightly different than if I'm using a post text context. And you'll see all this if you go through the documentation and things of that nature. But just know, if you are developing something, it is best to prepare for however they want to talk to you. We'll take it, but make sure if you're writing it in code, you have to do your due diligence as well. Obviously, we're doing this here in the console because we've already built this, but in code, I always make sure that I'm able to take either one. So, okay, I want what type, thick or thin? It's not going to like that because I've just been running my mouth, and it's going to go, I have no clue what you just said. So, oh, I said thin, good. Okay, so my response is kind of hokey because I was just rushing, but it's ready for fulfillment. It says, okay, do you want, the type is cheese, the piece is large, the crust is thin. All right, that is a bot, and I will start doing one really quickly, but we're not going to have time. I'm going to start one in 3 minutes. I know I have to do the 5 minutes for talking, and I haven't even finished my slides, but I will do it quickly. So if I was create, you have some sample ones. I won't go through that. That's boring. So if I wanted to create a bot about, we could create literally a bot about DevOps, right? If I wanted to say, what's the next session, right? So DevOps UK, I choose my, oh, what did I, thank you. I'm typing too fast. I can choose my output.
Hello, my name is Kimberly.
It tells you what it sounds like. Kimberly has a little husky voice there. That's fine. And then we do the warning, hey, if you're writing this for a child, you need to make sure you're doing the right thing. So I'm not. I'm just doing it for you guys. Wow, that 3 minutes went fast. Okay, so just really quickly, I'm going to create an intent. Let's say my intent is, so you can do one that's already there, but I want to do a new one. Let's say my intent is conference schedule, right? And if I hit add, and then I will do the sample utterances that I want to know. So I could say, well, yeah, what's the next session? Right? And I could add that. Here's the trick. What is that? It can detect a time because I can actually put a time in there. There's two things. I can make custom slots, or I can take slots that are already there. Similar to slots that are from, let me make this a little smaller, and time is really flying. So you'll see here that I can use slots that already exist, or I can make my own. So the pizza types were ones I did my own. The sizes one I did my own, but there's a bunch of them. So region, city, actor, airplane, blah, 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 the date. So let's say I required a date. So if I said, or rather a time probably would be a better one. So I could require a time. So I could say, what's the next session? And then be like, okay, well, what time are you interested in? Blah, blah. Now I'm at 6 minutes. But you can actually build a bot that does that. And I really wish I had time to do that. So, if we wanted to build a bot, for instance, I could say Amazon time, and the slot for the time was like session time, and now my thing is turned red and said I only have 5 minutes to go. So I will not finish this bot, unfortunately, but come see me if you actually want to, because that might actually be a cool thing to do. So let me finish up with, I should hopefully be at the end. Yes, okay, good. I didn't time it as poorly as I thought I did. Well, I did because I didn't finish my bot, but okay. I'll pretend like I had the right time, right? So here is the summary of all of this. You can absolutely start your deep learning today, right? I did nothing. I configured no models. I didn't go into machine learning, even though I do things in MSNet, and I think it's really fun. But if you're just getting started today, you can automatically put things like natural user interfaces in your application, or facial recognition. And typically, you would have to have created a model to do that before. All of these are available to you without you ever doing a model or creating a neural network. Now, I hope you guys will get into it and create more neural networks, but again, you have the ability today to do that. I wanted to make sure I ended on how do you get started with this in code, because I only got to show you just the Java code for recognition. And the second part of that is us adding a button and put Polly in that where it could talk back to you. Not a lot of time there. But there are samples out there that you guys can take immediately, and they're in all languages. So whatever language is your favorite, you can use for this. But these are just a few. There's a ton more. But again, I wanted to make sure that you guys had an opportunity to start, just in case I didn't finish all the code, which I didn't. And then with that, 4 minutes QA. I almost did the 5 minutes right. See, you didn't have to fuss at me. Yes?
So the types that you had available there, I noticed you had like musician or film or things like that.
I'll go back to it while you said.
Slot types.
Mm-hmm.
Is that like a finite list, or can you add to that? Can you customize your own types?
Oh, absolutely. So so I'll just add, session time. So I'll say, what time. So we'll just go ahead and finish that and add that, right? Yeah. So now I have that slot and I said it require. But what if I said, I want topics, right? Yeah. So conference topics, right? Right? That's what I wanted. What I would do then is, instead of here, I would go and actually create a slot type. So I can say I want, conference topics and blah, blah, blah with the, description. And I could give some sample responses there. Now, here's where the great thing where the code comes in. I can give sample responses there, but I can totally expand that by tying when they respond to a Lambda function. So asynchronously and servicely, it'll go out and say, okay, here's all the topics. Let's say you have all your topics in the database. And it could fill that slot with more than what I have here.
Possibly that slot type is there because it helps Alexa or Lex match your speech. So say you only do musicians, then it's a finite set of like musician names or something like that.
Actually, it's not. That's the great thing about it. This is just really a placeholder so it knows. So for instance, let's say I only do 2 topics here, right? Let's say I just do, serverless and AI, right? I'm going to save that slot type. And so now when I'm taking a conference topic in here, I can now put conference topics as one of them. Here's the great thing about that. I can then take whatever you say coming in. Once I get that slot, and I'll actually show you the Lambda function in the 2 minutes I have left of the bot we were going to build. I can take that slot, because now I have a slot type created. I can say, okay, I got this information in. What are the accurate validations for these slot types, or what other slot types do I want? Because this is my own slot type. So that way I can go out to Dynamo or Mongo or whatever. I already have a start of a slot type and said these are actually all the correct slots that are available for this. So you don't have to put it in here. It's not a finite thing. It's just really a placeholder of some sample ones so you can test in a console. But if you're building in code, once I get the slot type in, I can then go out to databases or whatever else and then fill that slot type as appropriate. I'm trying to think if I have one that does, okay, let's see. This one I was showing some folks, I think I altered the sample. Let's see if it has it here. Yeah, so here's one where I'm actually doing validation, right? So I allow them to put in any type of flower type. And I actually built a slot that only has, my time is up. I built a slot that only has one flower type, that's roses. But in my code, I actually take in the flower type here, and then I go out and say, these are the flowers that I will accept. And those flowers are absolutely not in my bot in the console. It's something I'm doing by tying it to code. So you have totally the ability to customize and have as many slot types or types as you want. I'm over time, but if you guys have questions, I will stand here quietly and answer them before he kicks me out. Any more questions? Yes.
Yeah, talking about recognition.
Yep.
Does it work with videos as well?
Yes. Yes, so actually the demo that I was going to do here, but my coworkers reminded me that I only had 50 minutes, was I was going to take FFmpeg and actually take streams of every 30 seconds and then have it give you the objects of what was on that screen. So I was going to actually take that and slice up a video, a short one, but that still would have taken some time and then slice it up, send that to recognition, and then have it tell me, based upon this scene in a video, what are the objects in there. So absolutely. That would have been a cool thing to finish, but the time wasn't going to do it. All right. So the guys who I promised you two, I didn't forget. Please don't forget to come up and let me give you the things. All right. Thanks, guys.